So this is an example problem on probability. A supervisor will choose a shift of 4 workers from a 7-person crew. How many different shifts of work 4 workers can the supervisor choose? So essentially, when you face a type of problem like this, you got to ask yourself whether or not this is a combination or a permutation. So the way you know is that the way you ask is, does the order matter? Does it matter? So if the order matters, then it's a permutation problem. If it doesn't matter, then it's a combination problem. So let's go in the handbook here and look at that. So in this problem, let me go back a little bit. So here you have a supervisor that's going to choose 4 people. So you got 4 people out of 7. 4 out of 7. Right? So the supervisor, he or she doesn't care the order of the 4 people. He just needs 4 people out of the 7 crew. So order does not matter here in this case. Therefore, we have a combination problem. So the number of different combinations, 4 people, out of n7 distinct object taken are at a time. So the number of different combinations of 7 distinct object taken 4 people at a time, basically, if you translate it in those words. So in our case, n is 7 and r is 4. So n is the total number of the object or whatever it is, and you need 4 people in this case, so you got to be taking r at a time. All right, so this is the formula. Let's write that down. So the combination formula is n factorial over r factorial n minus r, all factorial. All right, so in our case, n is the total number, that's 7, and you got to take in 4 people at a time, regardless of the order of it. So r is 4. So our formula becomes 7 factorial over 4 factorial. 7 minus 4, that's 3. So we can put 3 factorial. Now you can plug this into your calculator, which I recommend. But just in case you for whatever reason you don't find it in your calculator, which is unlikely, but just in case, if you remember factorial, that's multiplying n all the way to n minus 1, I believe. So you got 7. So if you have 7 factorial, that's 7 multiply by 6 multiply by 5 multiply by 4 all the way to 1. 3, 2, 1. And you got to do the same thing here as well. So 4 factorial is 4 times 3 times 2 times 1. But you don't have to write the 1. Well, we can write it anyway. So that multiplied by 3 factorial. So that's 3 times 2 times 1. And I'm doing it just because, but you can plug this into your calculator, which is way faster. So here you can cancel out some factors here. So this goes away, right? So the 6 also goes away. 3 times 2. So you have 7 times 5, 35 over 1. So this is 35. So the supervisor can choose 4 out of the 7 people 35 ways, 35 different ways, regardless of the order. So you can take A, B, C, and D out of, whatever, or you can take subject number, I don't know, O, P, Q, R, S out of the 7. So you have like 7 combinations, 7 different people. You can take 4 out of those 7, 35 different ways, 35 combinations of the 4 out of the 7 people. That's what it means. So when you're given a particular problem like this, always ask yourself, does the order matter? Then you can go from there, whether or not it's a combination or a permutation. If it's a combination, identify what's your total number and what's your N and what's your R, and then plug in into your formula and calculate the final answer. Pretty straightforward.